All right. Hello, everyone. It's been a little while since the last time I did one of those live streams, mostly because I had a trip to the US like 3 weeks ago to go see some friends and hang out for a bit. Then the week after that, I was back home but did the Incus 6.7 release and the release announcement video. And then last week, I was over in Europe for a customer meeting. And now I'm back home, and so far, unless anything changes, should be home until the holidays. So, gonna try and get back to more frequent live streams getting towards the end of the year now. And kind of as usual, as far as topics for live stream, I'm using the opportunity to make some progress on Incus OS. So moving back to that and we'll do as usual. I'm gonna give a bit of an update as to where things stand since the last live stream, and we'll take a look at some of the newer stuff and what are the next steps. So, as a brief reminder, Incus OS is effectively an immutable Linux-based operating system that's designed to run Incus and be pretty easy to just write on a USB stick of some kind, plug into a machine, boot the machine from that, just run Incus and all of its dependencies, and not have to care very much about dealing with the day-to-day maintenance of the Linux system or dealing with updates even for Incus itself. So to do that, we're using a tool called MakeOSI, which comes from the sysupdate project. It takes a bunch of mostly INI type config files and builds an image out of it, or in our case now, a bunch of images actually. And you can then put that onto like usually a USB stick and then put that into a machine, boot it from there, and you're all good. In this case, I'm testing everything inside of virtual machines because it's far easier until we get really satisfied with the result and start to actually run it on real systems. So in the live stream, part of the goal was to get system extensions working properly. So that's effectively a way to layer different images. And we've got that pretty much set up now. So here I've got the IncusOS repo open. Let's see if we can make that slightly bigger. Yeah, there we go. And if we look into the list of images, we actually have 3 images these days. So the base one is effectively your, I'm just going to get the camera down a tiny bit. There we go. Is effectively your bootable image itself. So that includes Linux kernel, a bunch of the dependencies, like effectively the bare minimum needed for the system to be functional. Then we've got 2 extra layers that can be loaded. One is Incus itself. So that includes the Incus binaries, QEMU, all that kind of stuff. And the other thing is a debug layer, which was suggested in a live stream and got set up pretty easily. It's actually just one file, as you can see. And what it does is it adds a few debugging tools that are pretty commonly useful. So things like curl, htop, fstat, also ps, strace, those kind of things. So that's now its own image. Then we've got a make file that kind of ties everything together. So we've got a few targets here to actually build the image, clean things up, and test it, where it effectively imported as an image into Incus and creates a VM from it. Boots up the VM with a TPM attached as well, and we can then also did a new targets to actually test those extensions, so the Incus and the debug image. Currently, I'm using that bit of a trick where I turn the signed images into unsigned by yanking out the Verity partitions out of that. You might remember from the last live stream, I was looking at making this work by loading things up into the virtual machine itself, so loading the secure boot keys and then using the kernel keyring to do the validation of those images. These days, I was missing a kernel feature last time, which I enabled, and that should be available now. I've not retested it since, so currently it's scripted to just remove all of the signature bits. But that's something that should be changing. Like ideally, we want the system to boot under secure boot, and if we see it's booted under secure boot, then we should load all of those images with their sending bits. And that's another piece of the puzzle that's not there yet. It might be maybe the next live stream, maybe the one after. We'll see how well the rest of the stuff goes. But one component that needs to be written still is an actual management daemon that runs on the system, and that will handle things like triggering updates, loading those extensions, managing all that kind of stuff. And that daemon will be able to figure out whether the system is booted under secure boot. And if it is, then make sure that we load the images fully signed. If it's not, then it can load them and effectively remove the signed bits and load them that way. But we'll need to properly mark the system as, hey, it's not as safe as it could be. So we'll have like a bit of a security status that shows whether you've got secure boot enabled, you've got TPMs, you've got all that kind of stuff. If everything is enabled, it's going to be super safe. If not, then it will still work, but with some features disabled effectively. So that's mostly where we're at. Other changes I did recently is I effectively rebased my local setup to using the current macOS I. I wanted to get to use some of the newer features, just play with them. To do that, I had to make a few small changes. So someone can see what I pushed today. We're effectively now overriding they call it the sandbox image, so the base image that's used to build other images, and injecting directly the repositories needed for Incus and for the kernel and the matching keyrings, which simplifies a bit some of the image build steps, and also makes it work correctly with the newer macOS I, where some of the changes we are making are no longer possible because that file system is now read-only. So anyway, a bit of reshuffling is wasn't needed. That means that for some stuff, it's quite a bit cleaner. Like if you look at the kernel install, it used to be that whole thing where we had a script that would download the keyring, put everything in place, etc., and then finally install the package. Now, because we effectively configured the sandbox to already have the repository right from the start, we don't need to do any of those steps. And all we need to do now is just put the kernel as in the module list, and we're done. So that makes it a bit cleaner, a bit simpler here. The other related commit to that, if we go look, is the one that will actually put that stuff in place. So it lets us use a new signing tool. I was hoping it would fix some of the enrollment issues we had. It doesn't seem to. So that's why we keep auto enroll off. But apparently, as soon as you start using this one, even with off, it still tries to do the enrollment and it's failing. But anyway, I need to figure out exactly what's going on there. The Incus side of things, well, the repo went away because we don't need to deal with it there. And then you can see the files I was showing earlier there, they've been pushed with that commit. So that's basically how things work here. Now, as usual, let's just do a demo of it, kind of working end to end. So I was actually in a demo VM here for testing. So let's just get out of all that. And I'm gonna build a new image. So that's gonna run macOS I, and we can see as far as like the differences, right from the start of the sandbox now, we have the two repos here for Incus and for the kernel. So that's the main difference. And as a reminder, we're using technically Debian testing as the base. So you can see me using one repo or another here and there. For Incus, we need to use the Noble, so the equivalent of Ubuntu 24.04 repo for some of the dependency names that have been changing. Whereas for the kernel, I can just pull the Debian bookworm, so Debian 12 build of the kernel, and just works. So it doesn't really matter, but you might just see in the logs a bit of a mix of the two, and that's why. So we're using Debian testing to get the most recent versions of just about everything, while still having gone through some amount of validation compared to Debian Unstable. So anyway, it's doing the usual dance that we've done with macOS I, but effectively it installed the base OS, the Linux kernel we need, it does some amount of work around that, then it installs the entirety of Incus, and then removes just Incus, so effectively keeping just the dependencies installed. because we want those in the base OS. But we then want Incus itself to be its own layer. So that's why there's a separate image that's being built as a system, the sysxt image. So I think at this point, we're probably actually building some of the sysxt stuff, or either the Incus one or the debug one. I think looking at the package list, it might be the debug one we're building right now. I don't know. Anyway, we're gonna have all of the images built in just a few more seconds here, and then we can look at how that works. Okay, so it's doing the packing for the image. So that's the main image itself. It's creating the initRD. That's another aspect that needs some optimization. The initRD is absolutely massive because it includes just about everything you can think of, which is good for compatibility, not very good for speed. So I need to improve that. All right, so image is built. If we go look at macOS images, output, you can see it generated. So the base, we actually have the base tree if we want to go look at it. So that's all of the file system. And then from that, it got us the image itself. So image raw is the raw disk image that can be booted. You also have a copy of the EFI, so the UKI image. You can see it's quite huge, mostly because of that initRD that's 553 megs large. This realistically, we should be able to get down to like 15 or 20 megs. That would make things significantly faster to boot, and using less memory for at boot too, because with this kind of size, you're gonna need at least 1 or 2 gigs of RAM just to boot the thing. Whereas we might be able to shrink it a fair bit to something smaller. But anyway, doesn't really matter at this stage, will matter down the line. Then for Incus itself, we can see there's a 395 megs image, which is the sysxt for Incus, and debug is 22 megs. So now if we want to test this stuff, we're going to just do make test. I'm just going to wipe my current VM, import the image into Incus, and then create a new instance from that and start it up. Okay, starting, and then we're going to get that weird error I mentioned around enrollment. So here we go, going through UEFI, then loading. So right now it's loading those 500 and something megs into memory. That's really the longest part of the boot, basically, is reading through that stuff, which is why I would be keen on shrinking the initRD to a more manageable size so we don't need to deal with that stuff. Anyways, once that's done, then we're gonna get probably the enrollment error. I think that's what I've seen so far. No, it didn't actually, huh? Okay. I mean, I did set enrollment to false, but last time around it still tried to enroll somehow. This time it didn't. So that's interesting. We'll see post-boot if it did the enrollment and somehow succeeded, or if it just didn't, which would make sense given the config says not to do it at this point. Anyway, the system is booted. As a reminder, we don't actually give a login prompt or anything, any kind of user interaction with the system. So that's effectively the booted state. Now, if I go into test Incus OS, again, as a reminder, we're actually loading the Incus agent in the VM environment for now, making it easier to develop. That's gonna go away in production, but there we go. So you can see there's currently we don't have PS, we don't have anything. It's pretty annoying as an environment to use. There's no Incus, and you can look around the file system, but that's about it. We might be able to check the secure boot state. Yeah, secure boot is disabled. So it didn't try to do enrollment, or if it did, it didn't really work. Anyway, that makes sense. And now what we can do now, which is new, is we can do that make test extensions, which then prepares and pushes the extensions into place in the VM, which it's actually what it did here. So it loaded both debug.ra and incus.ra. Then it checks that they were loaded into systemd, so we can see them both here. Then it asked it to apply them to the system, which it did. And once that's done, running systemd sysusers, which loads up the, creates the user accounts that we need for Incus. And once that's done, start all of the Incus systemd units. And after that, hey, we get to actually go and run admin init auto, which means that if I go back in there, not only is it more pleasant to work with because I can actually run debug tools. I've got PS, I've got strace, I've got all of those things available now. So that's pretty convenient. And we can also now interact with Incus. So Incus is up and running. It's using, I believe we're using the daily build. So it does show 6.7, but it's actually the current daily. And if we go and take and run a container, it works. We've got, you might remember there was some issue with SSL certificates last time around. That's fixed. There's also, we effectively have the, actually, I'm not sure how we fixed that one. Let me check. I think we're just creating the symlink, right? Yeah, so we've got user share certs, which is the contains the CS certificates, and it says at CSSL certs is a symlink to that. So it's probably the make file that's creating that right now. Let me see. No, it's not. What creates that? Oh, yeah, okay. So I think I did it properly. The way you do that, because we need that symlink to be created. As a reminder, /etc is effectively empty on boot. So yeah, Jared is asking what was the issue, the TLS issue again. So basically, with those immutable systems, the way they're built, the only part of the file system you actually have on first boot is /user. So any file that you need that's not in /user needs to be effectively created on boot. And on most system, etc SSL certificates, that is not created on boot. That's actually stored there, and that's where all of the trusted certificates are. So the way we worked around it is, if I look, I think at images, base, there is in conf.d 90 certificates.conf. So that makes sure that effectively wipes user share CS certificates because that's a pretty pointless directory in our case. We only care about the combined file. And it also runs a script. And what that script does is it copies during the build etc SSL cert CS certificates to user share certs, so that we've got the file over there. That's fine, but that's not enough, because when you do that, then nothing knows to go look at user share, whatever. To fix that, we need, I'm trying to remember what that is. I think it's in extra and repart. Oh no, it's in temp files. There you go. So we use systemd temp files, which is probably the worst named piece of software at this point, or at least close to that. Systemd temp files does far more than doing temp files. It actually is pretty good at creating persistent files too, which is exactly what we're doing here. So effectively, this gives it a rule of make sure etcssl exists as a directory, and then make sure that etcssl cert is the same link to user share certs. That runs on boot, and that puts in place what we're seeing in here, where on the read-only OS partition, we do have user share certs, CS certs, and then on first boot, systemd temp files runs and creates etc SSL, and then creates a symlink in there from certs going to user share certs. And with that in place, hey, everything works fine now. Oh, cool. We actually have Dan on in the chat too. So we actually have the main upstream for macOSI on here, who's been pretty helpful at unsticking the issue I had earlier with moving to the newer macOSI build. So that's been pretty cool. Yeah, so we're using systemd temp files to put that in place. Now on boot we get an /etcssl that's functional, which then gets us, in this case, with the sysext in place. Incus works, we can list, in this case we just created a container, and we also added everything that's needed for VMs, so we can go and create a virtual machine. We've got QEMU, we've got everything in place. So that should work fine. The other bit of kind of hard-coded stuff we have so far is the network config. So currently, what am I doing on that? Let me just check. Too many things. Oops. Git grep start. Yeah, there we go. So we're just putting a config file in place in userlib systemd network, which just runs DHCP and IPv6 config on ENP5S0. Works great because I'm running it in Incus with a single NIC, so that always will be the right name and everything works. Not gonna be what we want in the final build of this stuff. Again, the OS management daemon we'll put in place is gonna be handling that kind of initial provisioning thing, where like on first boot it will notice that, hey, I'm on first boot, I need to actually go and pull the right system extensions. I also need to go look at that provisioning profile I've got on disk, pass the profile and generate things like the network config, so that we can then bring up the network with network D. But hey, that works. That works just fine. We've got network, we've got Incus, we just created a VM. Everything works just fine in a pretty restricted environment. So yeah, Incus is quite happy, which was the goal of the last live stream. Now we're gonna have to go look at something else I've not really played with yet, but we've got some pointers on how to do it, which is good. So the goal with this live stream is to start poking at another component of the old systemd immutable story, which is systemd sysupdate. So we can actually look at the man page for that guy. Okay, I think I showed that one before. So effectively, systemd sysupdate lets you handle the well, it does like multiple partitioning schemes. So doing A, B. So you've got double. I guess as a reminder, I should probably show this again. So if we go look at our partition tables, so make OSI output and then the image itself, so image.rar. Sure. Okay, here we go. So we've got the EFI system partition here, which has stores the UKIs and that stuff. And then we've got the by default effectively. So that's not what you have on disk after initial boot. What you have on disk prior to that. You've got the user partition, which is using EROFS for its file system, so fully read-only. And then we've got a DM variety tree next to it so that we can set up a DM variety device and read through it to make sure nothing was altered compared to the expectation of that variety tree. And then we've got another partition with the variety signature, which then gets us the actual chain to make sure that nothing was modified. The OS also boots with so effectively the UKI has pre-baked into it the expected root hash for the variety tree. So again, on boot, effectively validates that this is the root of the tree, and then the entire from that point on, variety validates everything else. Yeah, I think effectively done. Just discover that point now on in the chat of it's the signature is not used on boot because instead the root hash is what's actually being used. All right. So that's effectively how that stuff is set up. So as you can see, there's only one set of partitions right now for user. If you want to do A/B and support moving from one image onto the next as sysupdate uses, that's gonna double the partitions for the user partition specifically. So we're gonna have, I'm not even sure how that works, so I guess we'll play with it. But we expect to see like a user x86-64 and then equivalent B for the other one, so that we can know which one is the A side, the B side, and when you apply an update, you effectively write to the side you're not currently running, then reboot onto that side. If something goes bad, then you reboot back onto the original. So that's what sysupdate does, and it also adds support for actually going over the network and checking for updates, pulling updates, either over the network or from local files. And rather than try and do everything from scratch, there's conveniently the particle OS repo under systemd on GitHub, which already makes use of that. So we get to go look at how they've done it and try to replicate some of that. Now, we can see in this case, they do have the make OSI sysupdate, and that's where there's probably going to be some more of the interesting stuff. I want to also look at the partition, so repart, to go see what that looks like. Okay, so ESP, that's normal, 1 gig. I think ours is 2 gigs now because our UKIs are huge. Okay, so this one has the label has variable here. It's got A and M. Do we have that? I don't remember how ours looks like now. Let's go look at report user. Report user has true. Don't we have label? Do we do label at all? We don't. Okay, so we might need to copy that. Let me check the doc for report real quick for what the variables mean, but M, I'm guessing, is the one that's gonna get replaced with the partition. The partition, which side of the system it is, if it's A or B. I'm guessing. And where are the variables for that stuff defined? Let's look for label. Yeah, not this one. Okay, so it's one of the linked ones. Report.d probably. Yep. Yeah, there we go. That's more like it. Label. Matching. Okay. Where? Oh, there we go. Specifiers. So, operating system image identifier. Okay, so I guess it's effectively being shoved into that identifier, so we can get the two sides maybe. We'll see. So that's probably something we're gonna need to do. The rest is otherwise ESP and the all three partitions. So it's pretty similar to our setup. Yeah, very similar. Okay. Then let's look at what else there's in there. Sure. And obviously sysupdate is kind of what I'm interested in. I've not looked at any of that stuff yet. So user variety, transfer. Okay, so that defines where to go and get a new update. So in this case, it's pulling from a regular file. We can have it also look on the internet, but we would probably try regular file initially. And then it specifies the target. So it's the partition, the path, is auto, match pattern, and which, okay, so M, and there's the @v, which is probably the version or something. Okay, I need to look at that particular man page to go see what the @v means. Sysupdate.d. There we go. Which one is that? Yeah, version identifier. Okay, that makes sense. So what's going to actually happen is that the partition label is most likely going to be including not just whether it's A or B side, but effectively what version it is, and we just go and replace the other one. Partition flag 0, read only, okay. So that just defines each of the partition. And then obviously UKI is a bit different because it's not a partition, when it's a regular file, which needs to get replaced on the EFI partition. Over there, and again, bunch of patterns, instances max. Okay, so that does define it when you want to. That's fine, that's what we want. Was there anything? I guess the partitioning is still where I'm wondering how that actually works. Okay, let's go look at what else they've got in there. So I remember looking at IncusOS a little while back, but it's gotten some update. So let's see. I'll put them. Okay. There's nothing unusual in there from what I've played with so far. I don't remember if we do this one. So it might be needed to, again, what's the name of the UKI in our case? I go look in here, boot EFI, Linux. Yeah, because that might conflict otherwise. Okay. And we've got the image ID here, which I don't even know if, do we actually set that yet? Let me check. So make OS sign, that's in the output, so that's probably in this guy. Yeah, output is pretty sparse, so we should probably fill in some of that stuff. So image ID, because currently we don't even have that. And then it's on the content side that we want to set the format for the UKI output, which is down here. Okay, again, it's this guy. So that should let us effectively generate non-conflicting images on that side. Just checking if there's anything else on this one that we need to also add. I don't think so. I think we're mostly fine. Okay. So let's see. There's that guy. What else is in there? Clean. Okay, that's not. Let's just clean up stuff. What are you doing? Finalize. Okay, so that's effectively copying. That's something we've been looking at doing. We've not actually had to do it so far, which is effectively copying etc from the build root, dumping it into user share factory etc, so it then gets copied back on first boot. Oops. Apparently I didn't read properly. And yeah. Oops. It's an image ID. Thanks. It's nice to have people catch the typos before I even run the tool. Thanks, Dan. Okay, so that's finalizing. Then what's run within the root is just, okay, so that's home config and some PAM stuff. Doesn't matter in our case, I don't think. Prepare, that's preparing the package manager, don't care. This one I've not played with before. Do I have the macOS IM page somewhere? Yeah. Oh, well, that seems like a good idea. Not sure what the default value would be, but that seems like something we should probably have. Oh, there we go. Image version, accepts any string, in which case, okay, but okay, so there's no real default value I can read. That probably makes sense. Let's do the same thing. Make OS version, and just a shell script. What they're using? Year, month, minute, seconds. Sure, that's fine. We can do that. Not sure that we need the. And probably do without the second. The image build takes long enough. It's not really possible to get two of them. Oh, interesting. History, yes. I missed that one. Was it on the main? It seems like actually setting some kind of version string is a good idea. Yeah, in the build. Okay, cool. Make OS side conf. Yeah, that seems to be. Oops, that was build, right? Build, yeah. Yeah, it's primarily as Dan was saying, that's primarily useful if using macOS itself to run the environment. So you can run it with macOS QEMU to actually run the thing. Obviously, in our case, we just load it into Incus, which then means we're the ones figuring out what the current image is and what to upload. So it's not as relevant, but we might as well do it. Because like down the line, we're not going to be always running this in the Incus. It's mostly for the for development. We're doing that now. Cool. So that's, I think I went through all of those. And then I'm gonna go look at what we have in .d here. All right, okay, so different options for the different images. That's just the package list they want in there and what to do afterwards. So that's just the content. It doesn't really impact us. We've got our own stuff already. Then Fedora is gonna be basically the same thing. Okay, that's fine. So don't care about that stuff in our case. Extra. Okay, so what's being put on disk? Bootloader, loader conf. Okay, so that's just so we have a chance to get into the bootloader. I guess that seems like a good idea. Then user, so that doesn't matter. What's in lib? Environment is probably not, yeah, not useful for us. Repart, that might be useful. Okay, so ESP, sure, that's fine. What else do we have? User, so that's the, again, with the labels set correctly in here. So we need to go set the labels on ours effectively. That's the part that's wrong. US user variety, because once we do, then we should be able to get multiple of those in place. Okay, and then variety sig again. What's in there? Huh, what's that about? So it's overriding the first one, which had a label, with another one that doesn't. Is that done for all of them? Yeah, so it's clearing the label on all of them. That's interesting. Let's see what if Dan has something to tell us about that. Then root partition, that's fine. We've got that stuff. Okay, so it seems like it's kind of weird because it's both like in the same image. We've got the definition for, so if we do sig here, partition type user variety signature label is defined here as the image identifier and architecture. And just right after, we've got a file that just goes ahead and overrides that. So effectively, for the same, oh no, does that just create another empty partition afterwards? Is that what that's doing? That would make sense, actually. Yeah, I think that's what it's doing. Okay, cool. I just misread it. It looked like it was overriding the previous one and then removing the thing, which makes pretty little sense. But I think what it actually does is that it creates, so it makes sure we've got the ESP, it makes sure we've got all three partitions for user, and then it defines the other three partitions for the update. So it creates the right size and everything to have a space to write the sysupdate, and then root and home D. So I think that makes sense. That's kind of what I was looking for. Like, we need to have somewhere that actually defines the size of, like, defines those partitions. So on first boot, when we repartition, we create those three spots before we create the root partition with the rest of the storage in our case. So I think that's how that's done here, and we should be able to just replicate that. So that part definitely needs to be done. I'll just keep that one open so I don't forget. And what else do we have? So in systemd, bunch of preset stuff. It seems like particularOS grew quite a bit recently. I don't remember it having quite so much done in there already. Yeah, that preset could be useful. Kind of for what we're doing with the make test extension, except we only need to do that after the initial boot, but that could be pretty useful to clean up some of the units and stuff. So I might look at doing something else. Actually, let me keep that tab open for something to look at. So that just adds the call to the preset. So we probably want to have that as well. Let me just shove the stuff to look at later at the end here. Because the preset we don't need for this live stream. Focus is really on OSI, on sysupdate. But I'm discovering some useful stuff as I'm going along. So that was for systemd, temp files d. What are they doing? They're doing more stuff than, yeah, they're doing a lot more stuff than we are. Creating a bunch of, yeah, okay. That makes sense. Like repopulating all of /etc. In our case, we get it because we don't really run anything that cares about the content of /etc. We can run it pretty bare. Like if we actually go look at the environment, that's what we have in there. So if if you ignore all of the systemd target stuff that was that's created on that first boot, you've got relatively little. A bunch of those are mostly placeholders, empty directories. So there's very little actually in /etc because we don't really need to persist much anything in there because we don't really run a normal full Linux distro. It's mostly just Incus being run, and then it doesn't really interact with /etc to begin with. But if we need to do more, then as I said earlier, temp files D is a bit of a badly named piece of software at this point because it's used for a lot more than that, and it's kind of the way to put all that stuff in place. Cool. So that's user lib. Okay, so that's all of the extra stuff. Was there anything else? Profiles. So that's for what we want to install on top, desktop, KDE, whatever. We don't need that. In the initial report, I remember we need to change the label on ours a bit, so that makes sense. We need to do that. And then actually putting this update in place. I'm also not familiar with the UKI profile stuff. So that's mostly out of interest. What's going on in there? Okay, so you can do profiles for UKIs now, and effectively let you do different command line arguments or something. That could be interesting. Okay. Just saying, there's a question around how we intend to do effectively unattended installs of Incus OS, and how we intend to handle kind of the initial provisioning. So different approaches on that. Currently, the goal is pretty simply put together an image. You can dump a YAML file on there, which includes your initial network config, and includes any keys that you need to see trusted. Then you just dump that on a USB stick, plug it onto any machine you want, boot from it, you're done. That machine boots up, gets an IP address, preloads Incus, and trusts that key, and you can just connect to it remotely. That's the easy-ish way to do it for the at the beginning. At scale, it's not going to be a good option. At scale, the goal is for the Incus OS daemon, so the daemon doing the provisioning and the OS management, to connect to a central point, so a different server within your infrastructure that can keep track of all of the servers running Incus and actually cluster them together. That's a piece of code that I currently have some people working on for me at my other job. So for those who followed very closely on LinkedIn, you might have seen that I started kind of second job recently. I still have my job as founder and owner and effectively only person at Zably who's doing Incus related work for a bunch of companies at this point. Primarily pretty technical folks who already used either LXD or Incus and want extra work to be done, support, training, that kind of stuff. And then I along with a few other folks, we created a new company called Future Fusion, which whose goal is to build a lot more of a solution around Incus that can be used by larger entities as a bit of a replacement for something like VMware, effectively. And as part of that work, we are mostly consuming all of the pieces of Incus, so Incus OS, etc. And in that kind of environment, when you're deploying thousands of servers, you don't want to go and do individual provisioning of the different servers and manually clustering and that kind of stuff. So that's where we're working on what we call the Operations Center. And the Operations Center is effectively a standalone piece of software that runs that all of the Incus OS systems can connect to on first boot, and then register and get their provisioning data so they can cluster together and they can be kind of managed centrally. All of that work is going to be fully open source Apache 2 available on GitHub. So we're not trying to do open core and that kind of stuff. Not at all. It's all open source. It's all going to be around. It's just not there yet. Like the Operations Center, we've got a design for it. We've got some initial code for it. We don't actually have an implementation for it yet. But I've got effectively employees working on that now to start filling in the gaps. So that's the idea for the larger scale setups, is that you'll be able to effectively grab manually build or grab a pre-built image of GitHub from GitHub for the operation center, run that in a VM or a container or something like that somewhere on your network. And then the provisioning profile that you put on each of those, the provisioning profile you put in your immutable image install will effectively provide the basics needed to get the machine onto the network, and then API endpoint and public key of the operation center. It can connect to it, and will work kind of like a unified dashboard for anyone who's been dealing with that before, like the Ubiquiti Unify stuff, where you can see your machines, your different servers showing up as being like in unified terminology, it would be like pending adoption. So effectively the same thing. Like we've got a bunch of machines that have been started, are registered, are around. We know they're up to date and everything. They've just not been clustered or configured yet. You can select them, cluster them together. That's the plan there. So there's a question around like the new code, like whether it's going to be under Zabli, Linux containers or what. So most likely it's going to be under Future Fusion, but we'll see. It might end up moving under Incus, under LXC. Just like we've got Incus OS is there, we could also presumably move some of those components there. Currently they're being developed under Future Fusion, but that might just move around. Doesn't matter too much, obviously, for exactly where they belong, so long as everything is properly open source, properly licensed, and everything's good there. Like for anyone who wants to actually go look at the high level view of that, that's the Future Fusion website. And there's the diagram here of the infrastructure. So FFCHOS, which is Future Fusion Cloud Hypervisor OS, is effectively Incus OS, just effectively a rebranded, rebuilt version of it as part of that solution. And that then connects to the operation center, so at the top left here, for the provisioning. And we also have another piece that we've been working on for a few months now to do migrations. So specifically connecting to like a full-on VMware vCenter type environment, connect to that and move those VMs over to an Incus cluster. So those are different pieces we've kind of been working on. Again, everything is technically licensed to under Repartitioning 2, just not been public, like pushed publicly yet, because we're still at the stage where we're refactoring half the code base every week, which makes it a bit hard to follow. But it's gonna be showing up on GitHub in the next few months. So that's kind of the idea, and like obviously IncusOS plays a very big piece of the puzzle there. Like we at those kind of scales, you don't want to have to deal with manually installed packages and all that kind of stuff. That's where IncusOS is super attractive. And again, as a reminder, we're not looking at taking away any of the other ways to run Incus. Like very happy for Incus to be present in pretty much all the distros and people to just install that locally on their laptops or desktops or servers. It's great. If you like managing full-on Linux distros, even at scale, we've got Incus Deploy, which uses Ansible and Terraform to manage Incus clusters of basically any size you want using normal packages. And then for those who don't want to deal with any of that, whether it's because they're not really familiar with all of that Linux stuff, or because they just want something that's guaranteed to be identical everywhere and be reliable with a full trust story that's nice and clear, then that's where IncusOS and all the immutable story shows up. So that's basically that. Back to digging through Particle OS, I think I was basically done looking at all the stuff. So I was looking at the UKI profiles, which not something we need right now. Okay, so to line things up with that, for us, we're gonna need to do the repart piece, which is mostly changing the labels. Well, the top level repart piece anyways. Define the macOS sysupdate, which again for the source is gonna be a bit weird for now. We can just put like a fixed path on the file system and use that for now. it's going to move to being on 9 instead than the 9, but that's fine. And then the on boot repart to actually make sure we've got the right partitions. This might be the most interesting one to do first, just because it's easy to test. Like once we've put that one in place. Well, actually, I think we'll do both. We'll do both of the reparts. So the first one should change the labels, and the second one should create more partitions. So we'll just try and put that in place, starting with the basic repart. So if we go back in the repo here, let's go look at macOS repart, and we've got kind of the same thing. So ESP, what was on there? ESP, VFAT, copy files, and the two things I think it's identical. Yep. We just are using 2 gigs in our case instead of 1 gig. So same structure. Then the signature, I think our partitions are in different order. Yeah, we've got user, variety, sig, so it's slightly different order. Anyway, doesn't really matter. Let's compare sig. So type is the same. Variety signature, match key user, so that stuff is all good. And then label, I'm not clear on what split name does. We'll put that in place anyways, but I'm not, I need to go look at the documentation for that one. Do I still have repart.d open? Yes. Split name, sorry for it not being dark mode for that page. Configures the suffix to append split artifact when the split option of systemd repart is used. Okay, order is important actually. Okay, so you need the variety sig first, then variety, then partition. If you need to grow the a user partition on first boot as well, it needs to be last. Oh, that makes sense. That would explain it. Yeah. Okay, so yeah, because if we don't, then it's just to repeat kind of what Dan is saying is that you actually want the data partition to be last because it's the one that's variable size, and if you don't, it's gonna create it on with the smallest size of the initial image, and then not grow it to a usable size, so we won't be able to actually put another image in there. That makes sense. I'm not sure if we need the split name stuff now. I'm kind of tempted to go without for now and see later if we need to. So let me just check what else we had. So type is fine, label is fine, the two variety stuff are fine. Okay, so now to Dan's point, we need to reorder things. So this becomes 10. 11 remains 11, and 10 becomes 12. So just making sure that the last partition is the data one, so that we can grow it. Cool. So sig is fine, assuming that we don't need that split thing. I guess we'll know soon enough. Variety. Okay, let's go check that. Yeah, so that one didn't have any size. So yeah, the size, I don't know actually how much size the variety tree takes, but obviously we need that to be big enough, because if it's not, we're gonna have a bad day. So minimize is probably not a good idea. That will be my guess. Variety hash, variety match user, yep. Then do size, type, and we're missing the label. So let's do label. Cool. And so that's the variety one. Sig we've done. Actually, was there any sizing on variety sig, or is that just fixed? Well, I mean, yeah, the signature is going to be tiny, so I guess it's always the same size. That's why it's not mentioned, because that should be counted in bytes how long this thing is. Okay, so that makes sense. User. Let's go look at user. So user is number 12 now. Okay, so user, again, we need to put the label. It's EROFS. We want user in there. It's a data partition. Key is user, that's fine. So that one has minimized, yes. Oh, and we don't actually do compression, I think, right now, unless it's done by default. So let's do that. I don't see any reason not to do this standard. It's nice and quick. Okay, so that's for as far as adding labels there. Split name is important to put the partition UID into the file name, which is picked. Okay, so that's what that does. Cool. It's convenient to have Dan around because that saves me from spending too much time reading the man pages or bugging him, which. Okay, so we've got, I did actually check, are they the same structure for all three? I just assumed they were, but maybe not. T.U, let's see. That would be a pretty simple mistake to make. TU is fine. I think it's the same on all three. Yeah, okay, what are T and U in repart? Sorry, it's gonna be bright again. Okay, there we go, specifiers. Partition type and UID. Okay, so that's what Dan was saying. Cool. So that's the main repart stuff done. Now the next one is the on-boot one. So that's in our case in macOS images base and then extra user lib repart. So that needs a bit of changing. Cool. Because currently the only thing we've got in here is the root partition and just telling it, hey, add a root partition at the end. Needs to be minimum 1 gig and we want it to encrypt it with TPM. That's what we have right now. That needs changing. So, and it looks like the numbers line up, so that makes sense. Yeah, let's go and create those. So 00 esp.conf. I was just contemplating cloning the repo and copy pasting the files, but we need to look through all of each of them independently anyways, so it's not too bad doing it this way. Then user sig. Oops. I mean, if GitHub made it easier to copy paste just the piece I want, that would be good. So that lines up again with our other files. So 11 user verity conf. Okay. Is user.conf. Let's do that. Okay, so that's what's gonna make sure we've got at least 5 gigs for user, which should be plenty for what we care about right now. That's what's gonna grow that. Swap, we don't care for now. So that being said, it's not a bad idea to have some. How much disk? I think I'm dealing with 10 gigs of disk right now, so I'm kind of space constrained on that one. Probably gonna actually need to bump past the normal 10 gigs since we're doing the AB scheme. That's probably not gonna fit anymore. Anyway, let's put a swap partition. It's a good idea to have one anyways, so let's do that. And we're just gonna deal with the Incus VM potentially needing a bit of a tweaking to have larger disk space. Okay, repart 30 gigs. And root partition is, oh, actually, I ended up skipping, I skipped the secondary partitions. Should not have done that. So, okay. So the 20s are effectively the secondary partition for sysupdate. So this one. And then 21 is just user verity. Let's go look. Okay, so that's again, it's reserving 400 megs for that. And then user will probably have similar sizing as the initial user. So looking at 5 max 20. Yeah, exactly. 5 max 20. I messed up my numbering, I think. That's 21 user.conf to be 22 user.conf. Okay, ESP, then the 3 partitions for the A side, the 3 partitions for the B side. The root partition should probably not be numbered 20, that's a bad idea. What was used here? Root was 40, which makes sense. Let's do that. Okay, so that should repartition on first boot with remain effectively keeping the existing ESP Verity Sig Verity, then grow the user partition to 5, what is it? Is it 5 gigs? I think it's 5 gigs. That's the minimum size. Yeah, minimum size 5 gigs. Then create again Sig Verity. So Sig is fixed size, tiny. Verity is 400 megs. User is 5 gigs minimum. Then swap is 4 gigs, and then the root is whatever's left after that. So that's good. That should take care of that. Now I'm trying to remember, where do we define the size of the actual output image, because that needs a bit of a bump. Output. Does it just figure it out? Well, I guess it figures it out, then you write it to the disk of the right size you want. And it's defined here. Okay, runtime 40 gigs. So, okay, that means it doesn't matter for building the image. That will be fine. But we're gonna need to change probably the testing script to tell Incus we want a larger image for that. Probably gonna go with 50 gigs to just give us something vaguely reasonable. Oops, Incus OS, make, so when we do the test, we import the image, that's all fine, but we want to do root size 50 gigs in here. There we go. Yeah, the mention of the, so yeah, it's true that like everything within the particular OS has the SPDX identifier for LGPL. Yeah, it's always, it's kind of interesting, like when you're talking for those tiny files here, because you end up with, there's not really many ways to do it anyway, so you end up on the fence of whether this is even really something that can be licensed or copyrighted, when there's effectively just one way to do it, and it's just effectively a config file. That becomes interesting. Okay, what the hell happened here? Base tree, make OSI output not found. What did I do? Could not train. Oh. Like if you were to take the entirety of that code base, then yeah, I would expect that would be a bit of a problem licensing wise. Just looking at the general structure, which is effectively a fancier man page to make OSI, that's fine. So just checking, I suspect that what happened is the images have a different name now. So if we look at output, yeah, things moved around. How do we handle that one? It's gonna be one for Dan. Hopefully he's still watching. So because what actually happens if you look at the image and we look at so it's probably when trying to build Incus or something. If you look at make OSI, it defines a base tree and dependency. So dependency I think is fine, but the base tree needs to point to the actual one. Oh, there's probably a variable for the version, isn't there? Let's see, do I have the make OSI man page here? Yes. It's in base trees. Because we're already using a variable for the path itself. So there we go. Specifiers image version v. Okay. So and that was just base underscore image version. So if we do this, maybe let's go see. It's probably gonna, I mean, it's gonna fail the other similar image. Maybe I should have fixed it too, because we're doing both Incus and debug. So debug's gonna fail for the same reason. I'm just tempted to see if the first one succeeds before fixing everything. But considering how long it takes to build the thing, I should probably have fixed both. to an aspect, like it actually builds the image pretty quickly. I think it's just like a couple of minutes or something out at this point, which is very nice. Just when you're doing it extremely repeatedly, no, it still ends up adding up. Okay, what are we doing? We're doing all of the Incus stuff prior to removing it. Okay. Okay. Okay, so that's the base one. Okay, not complain, base 3, make website output base. Okay, so it's still, it's hard to tell if it's because it's tried to do debug first or what. I should really have fixed both. That would have been a better use of my time here. Let's do this one too. So base 3. The dependency, I think, should be the name of the image, not the resulting artifact. So we should do that. And I suspect it goes in alphabetical order, so me fixing the Incus one when there's debug was probably the wrong bet there. Okay, would be nice to see that giving us a valid image, then booting it, saying that we have the new partitions all created. Then the next step would be actually making use of that. So that's effectively putting the sysupdate files in place, which we can do. I don't think we're going to be able to do an actual update today, but we can at least put the things in place and make sure that systemd sysupdate seems to see everything in place. Okay, so I don't want this live stream to end up lasting too much longer. I can probably do another 20 minutes, making like a nice and round hour and a half, but after that it gets a bit too long. All right. Looks like okay, so that's definitely building the debug layer now. So well, debug sysx now. So that was fine. I didn't need to put that underscore version thing. Huh. Okay, so there was something else. Oh yeah, okay, I know. I'm the main image. Question of like, not sure if giving permission for the license on Git on YouTube will hold up in court. Yeah, that's a good point. Probably not. Especially since I'm not sure how well recorded those chats are. Okay, so the base tree was wrong too. That's probably the only thing missing here. Let's go. That should give us a functional image this time around. So yeah, I'm interested to see what the default partition layout looks like after this, given that repart is given like a minimum size, maximum size for different partitions. I think I'm probably also going to end up being slightly generous right now, especially since we turn on compression as well. I don't think we're going to need anywhere near like the 5 gigs. The problem obviously is you need to figure out what's going to be the size you need, 5 years down the line, basically, because after that first boot, you don't get to really go back and change the size for those things. So I don't want to be too tight. In our case, the base image shouldn't grow too much. If anything, we want it to shrink because we need to remove a bunch of the kernel modules. My gut feeling is that we can probably do 2 gigs for the root partition. Well, 2 gigs each for the root partitions. I don't know how to figure out the size of the verity data. So currently we're looking like with the tree we're looking at, it's 5 gigs minimum size for user with 400 megs of verity data. So it's about 10%-ish. So I don't know how that works. Dan is saying there's something new that was added around verity. So yeah, I don't know exactly how big like the tree is. Obviously, it's gonna depend on the depth of the file system, or on the depth. Oh no, because it's a block. So I'm not sure how that actually works then. If it's fs verity, you could see it grow based on the number of inodes and the depth of the tree. But this is DM verity, so it's block based. So it should be a direct correlation between size, like used size to verity size. Anyway, we do have an image now, so let's go look at that. I do have, where was I running gdisk before? Here. Oh yeah, it's gonna also be using the new naming, so we can see it's now IncusOS .raw. So I'm gonna need to change the tests to handle that a bit better as well. Okay, so we got 2 gigs ESP, 16K for the roots of the tree, so the signature of the verity tree, followed by 400 megs. That's actually funny. We got 400 megs for the verity partition, followed by 335 megs for the base OS. Oh, okay. So there's an algorithm that the kernel uses to figure out the size, and that's been re-implemented in Repart. That's interesting. Yeah. So I mean, my gut feeling here is that 50 megs ought to be enough with what we currently have. But since we probably want to plan for this guy here. I mean, looking at the value right now, I would guess going up to 1 gig. So 100 megs, 1 gig would probably make more sense as far as values. I'll tweak that afterwards. For now, we can just see if we can actually make this thing boot, which would be nice. So I need to change the test script a tiny bit. For now, we can probably do just a basic glob pattern that should do the trick, I think. So if we do something like that, we don't need to pick the newest and not new. No new option, size max bytes for verity partition will size it to the max needed hash bytes for the. Oh, okay, cool. Oh, that's pretty nice. Okay, so you just set the max bytes for the data partition, and then it just calculates the verity partition size based on that. That is pretty nice. It will definitely be useful for this. And by the time we actually have partition images, we should have a version of systemd that supports that, so that would be nice. Okay, so that should be fine as far as importing it, booting it. This one is also going to be all kind of broken now. I suspect. Yeah, same thing. They all underscore the version, so just do that for now. I suspect it's gonna be obviously the new setup makes it so we can rebuild and get a different newer image, which is gonna be great for this update. Gonna need to just write a tiny bit of logic in that make file to pick whichever is the newest image. So basically listing them and sorting them and picking highest value. That will take care of that. But currently we only have one image, so I can cheat, and that should be all right. So let's go do make test. It's deleting the current VM and converting that one. I don't actually remember if I've got gdisk in the debug image. I don't think I do, which is unfortunate. Would have made this a bit easier. So make OSI images debug. What do I have in there? Yeah, I don't. Okay. There's still a trick we can pull for that. Anyway, waiting for insanely large UKI to load. Really need to do something about that at some point. Okay, and it's booting up, but failed to mount this user. Okay, what did I mess up? EROFS algorithm 3 isn't enabled on this kernel. Oh, that might be a problem. I suspect algorithm 3 means the standard compression. Oops, let me go check what I've got in this kernel. thought we usually had pretty much everything enabled, but I guess not. Yep, it's definitely missing compression. So that's a problem. Okay, well then I need to rebuild the image. So, where did I put the Z standard stuff again? Was it in? It's on the user partitions here. Yeah, this guy. I don't think it's mentioned in the extra files because that wouldn't make too much sense, but let's go check anyways. Extra user lib report and web user. Yeah, it's not, which makes sense, and 22 user also doesn't have it. Okay, while we're at it, we might as well shrink that stuff a bit. So for now, we're gonna go with 1 gig for this guy, max price 1 gig, and same thing for the other one. So let's do 1 gig, 1 gig. Okay, and Verity, so that's 11. Verity. Okay, so this one doesn't have a size because it's pre-created. This one has a size. So let's do 100 megs. And then on report 11 Verity, let's do 100 megs here as well. Oops. Okay, it's fine. And just check user. All right. So that should work, hopefully. Yeah, Dan's mentioning that like the tricks that can be done to select modules. So effectively you exclude everything and then you include the default set or you include specific patterns. Yeah, that's definitely going to be the next step to try it out. It's going to be interesting once we start using this on hardware, but I should be able to at least come up with a set that makes it boot fine within the test VM, and that ends up making things a lot faster by not having a UKI that's what was it, like 530 megs large or 550 megs large, because that's pretty darn crazy. Once we need to boot on actual servers, that's going to be a bit trickier because there we're going to need to deal with like all kind of weird RAID controllers and crap. But we're still like a bit far away from that, so it wouldn't make a big difference to need to switch the module list to something tiny for now. So I'm gonna test those two. I think I actually saw them in they were in place in IncusOS as well, I think. I think I saw them earlier. Yeah, exactly. So they're here. Exclude everything, include default set. So anyway, that image should not, it's going to be interesting actually, because it's not going to be compressed anymore. So we'll get to look at the size difference. We don't have it anymore around. Let's see, was it in this terminal? No, it wasn't. But we were like 300 something megs for the user partition. So we'll see what it looks like when it's not compressed. Not really sure what to expect because it's not like we're shipping a ton of text or anything that's easily compressible. But maybe, I don't know what to expect. 500 megs maybe? Let's see. So it's gonna be, obviously the image has a different name now. 1447, there we go. 810 megs. Okay, yeah, so the compression is not there for nothing. Okay. So I need to add that to my kernel config so we can start using it because that's a massive difference. Far bigger than what I expected. So yeah, interesting. It still fits within the values I've set, so that's good. Now the only problem I've got is obviously I had to put those nice glob patterns, which are not gonna work anymore. So let me actually go look at what we need. So I mean, this is cleanup. I don't care much about this one, but here. So for the raw image, we're just gonna straight up put the one we want for now in there. And I'll deal with cleaning that stuff up and actually, actually putting a tiny bit of shell that picks up the highest version. So that's the debug one I want, yeah. And then Incus is here. Cool. All right, make test. Right. And now to wait for that UKI to load. While it does that, what we can do actually is need to get a root shell on this guy, and we can actually go look at the partition table on directly in the VM. So from this side, which one is it? Test Incus block, this guy. Okay, so currently we can see it's not obviously not run repart yet, so it's still what we had in the file, except that we can see it's in a 50 gigs on a 50 gigs disk now. Okay, kernel's booting up. It should then go through repart, and we'll see what that looks like. One systemd is actually running. On the upside, we're not getting an EROFS error yet. Okay, and systemd is booting. Cool. And we've repartitioned. Cool. All right. So first three partitions are fine. What the hell? That's good. That's good. Why is my Verity SIG partition 20 gigs large? Well, 21 gigs large. That doesn't look right. I don't remember the Verity partition having a size set in there. Was there? So in user lib repart d. It's missing a bug fix from 257. Okay. Because yeah, this guy doesn't set a size. Can we set a size on there? Drop repart work. Oh, okay. There was a workaround. Okay. Yeah. So it's drop repart workaround. This guy. Yeah. Okay. It was setting a size. All right. So that makes sense. Yeah. So I guess we'll do that for the time being. We'll just set the two Verity partitions effectively. So the first one took the right size, so the initial one, but the secondary not so much. And I guess putting the workaround just make sure they both have the same size at least. So I guess we'll do that and just deal with the 10 megs when we could do 16K. Until, so what's, because we're using systemd from Debian, so we need 257 to make its way into testing, which it should. So we should have built with this guy, but it was still the RC. So maybe that got fixed after RC too. Anyway, let's just put the workaround for now. Then user Verity SIG, this guy. Yeah, don't have the right thing and I paste buffer anymore. So 10 megs on this guy, and then make OSI images, base, make OSI extra, user lib repart, and we're looking for 20. Yeah. Okay, so I will take care of that next time around. And yeah, we see technically we've got the three partitions. Obviously, this guy is the wrong size, but the rest is fine. Then 4 gigs, and then it picked whatever was left for the root. Okay. Now, if we go and exec in there, and we can load the extensions, that should work fine. Loading that. Systemd sysx merge no medium found. What happened this time? Systemd sysx list. Okay. They've both been stripped of. Oh. Let me check something. Like, why they're not loading, but because we changed the repart order, that's also changed the partition order within those, I bet. So that's gonna cause us a problem. Output. So if I look at Incus, say this guy, yeah. This guy. Yeah, there we go. Okay, no, so it's root, verti, and sig. So it's the same order. So I think the sysx always have the same order. That's fine. So then, why didn't it work? Okay. And if I do incus raw unsigned, yeah, it's the same without the sig partition. So that should have worked. Failed to read the data for image debug, no medium found. Huh. Kernel log. Mounted with retainer. Okay. Not really seeing an error here. This is weird. So debug.raw. What do I have there? Oh. What the hell? But file system. Oh, okay, yeah, but it's multi-partition, that's why. Okay. I've never used. Okay, I don't actually have systemd dissect, unfortunately. Do I have? I've got a set up, but I don't have kpartex. But why wouldn't it be? I didn't touch anything. I should have messed up. So it just goes with no medium found. Yeah, and don't have that installed. Yeah, systemd container thing has it. Systemd, does it just like go back and forth between them? No, it's the Incus one it's complaining about. Oh. Does that work on the actual command log level debug? That does a bunch of stuff. That's cool. Does it actually load, and if did it actually read anything useful there, or just dumped it into the daemon? Okay. Check exclusive lock, fire the loops. Open was quicker, short tingled verti. Okay. Mounting. Okay, so it's trying to mount. Checking for extension released. Okay. That's new. Yeah, let's see. System. I think I might have systemd dissect on the host. Yeah, I do. Live debug session with Dan. macOS output incus this guy dot raw. Well, yeah, gonna need to have a bit more in the way of privileges for that. Systemd dissect macOS incus. Okay, so that's the unmodified yet. Now, if we look at the, where is it? Incus.raw unsigned. Extension for system is not on this time. So here it is, system init RD portable service. Okay. And then, so if we compare with the unsigned one, we lost all that stuff somehow. And then, so all we should have lost is the third partition, which we did. What I don't get is why this worked just before. And now it doesn't anymore. This is weird. The same size, same everything. Yeah, it's signed. Well, no, there isn't. So there's no, the certificate, yeah, so exactly. So the certificate is not in the VM, which is why what we do, and that was working fine before, is just we use sgdisk to go and destroy, to get rid of the Verity signature partition. So we end up with the same image without the third partition on it, which was normally enough to have it move on, loading and just not having, not loading it with the signature. But I don't get, like, let me check the script to make sure we don't do anything else in there, but I'm pretty sure it's, okay, so we just copy the raw image into unsigned, sgdisk, delete third partition on both of the unsigned, and then push it. Okay, so there's nothing weird that should, like, we don't repack it or anything, so it should be fine. So it said there's an M3 thing. Is that right? Maybe I'm blind. I'm not seeing M3 on there. Yeah, probably too old. I'm running Debian stable, unfortunately. It's probably too old. This is bizarre. I'll do some, gonna have to do some debugging on this one. Yeah, you probably don't want to see what version of systemd I've got on there. It's 252, so it's a bit old. Which normally doesn't really impact macOS since it runs its own tools layer with the newer systemd, so that's fine. It's just debugging it here that makes it slightly annoying. This is kind of weird because it worked earlier today, then I changed the report stuff, and now it doesn't. I mean, we can just look at Git for anything that changed, but does that work? Okay, so let me run with system make OSI sandbox systemd exact. Yeah, 257, sweet. Okay, and that should have that M3 thing. Yep. M3, and then make OSI image output incus.raw. What? I'm confused. Why is this thing supposedly encrypted now? Ah, okay. Okay, so it says it's signed, so it refuses to mount it. That's fine. So let me use the unsigned one. Yeah, unsigned seems to be listing. So we're missing stuff in there. I see the extension released the stuff here. Yeah. So that's there. Is it confused by the fact that there's a version? Does that need to line up with the name of the extension? Is that what's wrong? Yeah, okay, so that is the issue. Cool. That will actually explain it. All right, so let's just try that easy enough then. Valid extensions and move Incus raw to that and move. So if it's really just putting versions everywhere, that's caused some issues potentially. List. I mean, not the best error. Oops, system dsysext list. Not the best error ever, I must say. Yep, that was it. Okay. Yeah, no medium found is not the best error to get in that kind of situation. But that was indeed the issue. So now with that in place, let's just run the rest of what we would normally be running. So okay, it's merged. Then we run systemd sys users. Okay, we're good. This and then incus admin init auto, and we should be back to having the let's do that again. 12 a working environment. Yay. Um, yeah. If you only go by what's available as air nose, yeah, that definitely limits your options a bit. I mean let me check. I'm pretty sure we also didn't have anything super clear in the journal, which is where it could have logged something more useful when we actually did hit the issue. Yeah, the journal is pretty useless. It just shows that we're mapping and unmapping the loop device, but there's no clear error in there. That's probably where it could have logged, being like, hey, mismatch or can't find the release file or something along those lines. That would have been useful. Anyway, that explains what the problem is, and it actually makes sense. Like we want to be able to switch different versions of the sysext as well. So having them be able to be listed alongside each other probably makes sense. Okay, so partitioning is good. We've got A/B side partitions effectively in place, minus the size being wrong, but just the next pre-build will fix that. We've got effectively generally pretty much the entire structure is now in place for doing sysupdate. Sysupdate itself is not in place yet, but we're kind of going over time. So that would be, yeah, it's actually a sysext thing, a macOS thing. So the question from Dan is like who's writing the extension release? But that's macOS that does it. On our side, if I look at the debug one, there's basically nothing in there. Like that's the entire definition of it, which is just we want a sysext. What the base is, extra packages, go. So that's what we've done, and then it did spit out the correct file name technically here. Like if I uploaded, if I had uploaded the file like this one as it is named here, and same for debug, so didn't rename them or anything, and loaded that, it would have worked. So I'm not sure how much it's macOS being to blame here or it's me. Like it's not, if the intent was for the name of the image to match the just the name in macOS side, and yeah, it doesn't line up because it includes the version. But the file name to the release info within the image does line up. So not sure if it's necessarily an issue. Anyway, now that we figured it out, it's fine. Okay. Okay, so the sysx should not include the version in the name. Okay. So yeah, then that would be an issue if in macOS I to change the generator there. Cool. So make some pretty good progress. I don't think we'll actually play with sysupdate on stream today because that would drag the stream into 2 hours territory, which we're already pretty close to. But at this point, looking at what we have on the particularOS side, it's effectively creating that folder, putting those 4 files in there, and the main issue basically for us is going to be figuring out the source. So normally you tell it effectively where to look at and the pattern like for files to look at to put an update. The initial code I'll push probably just in a few minutes or in the next few hours is gonna be to look at a fixed path like /update or something along those lines. Just look at that, and then we can test it by pushing the next image from the host through Incus file push into the VM in that path, and then kick in sysupdate to apply the update and then reboot it, and that should take care of that. Obviously, we're gonna want to switch that to pulling. Well, I'm not actually sure yet. From what I remember, sysupdate can pull from the internet. The question is, can it do like full HTTPS validation, all that kind of stuff, or not? And if it can, do we want it to do that directly? Like we can have it pull from the internet, from wherever we've got our images. Okay, so yes, it does HTTPS. Sweet. So yeah, we could have it pull a full image from the internet and then reboot onto it. That might be a decent first step, especially if we get IncusOS to start splitting up images through something like GitHub Actions. Because then with the right pattern, we might be able to have it go and pull those images directly from like a GitHub release or something like that. Or most likely what we'll do, because we're gonna need also a solution for how to pull the sysx, is that the Incus OS daemon that we're gonna be building is gonna handle that part. So actually go figure out the next image, potentially do binary diffs, potentially do those kind of tricks to keep updates small, pull the files onto the system into the folder that systemd sysupdate expects, and then run systemd sysupdate on the system to just read the files, write the partitions for us, handle the ESP, so the AFI system partition for us, doing those pieces. And then we're effectively done. We'll do the same thing for sysx, where we can also do like either pull a full new image or pull a binary diff, reassemble the new sysx, and then like effectively remove the layer, put the new layer in place as a way to update that. So I suspect we're gonna be always using it with just local disk as the backend, and we'll just download have the OS daemon handle pulling the updates and putting things in place. But it could be interesting to have it look over the network just as a test initially. That might be pretty interesting, just to see it do it. All right, so that's been pretty good progress. I mean, it helps a lot to have Dan in the chat. I realized, like, normally there's probably a good artifact of it being Thanksgiving break or just a quiet day or something. But usually I bug Dan on private chat on the side whenever I get stuck with macOS. So having him just be around here and answering questions immediately, that was very useful. Oh, parental leave. Okay, cool. Well, congratulations. But yeah, that's definitely been been useful to have him around on this one. And I think we're basically unblocked on sysupdate, and once I've got sysupdate in place, I think as far as macOS is concerned, we'll be good. Like we're gonna have our images, sysx, all of the updates, all of that stuff in place. And the rest is gonna be mostly about, well, we need to add a few more files in there, we need to add the daemon in there, we need to add a few more things here and there. But that's just, that's focusing more on the actual content of the image than the building process for it. I'm also looking forward to actually having this be built through GitHub Actions, just so we can actually get build artifacts that anyone can download and play with if they want to. I think the one thing I might still end up having to do some debugging on is the whole enrollment part on UEFI. For some reason, when I start my VM in without secure boot, so secure boot but in setup mode, it does not do the auto enroll correctly, even when switching to the new system DSB sign. So I don't know, there's still something weird going on there that we want to figure out. Because it's a bit of a pain if we have to tell people to go on in their firmware and load the DER version of that certificate into their secure boot DB and then boot from there. It's kind of frustrating. So if we can get the auto enroll working properly, and the only thing we need to ask is please move to setup mode and then boot, and you're good, that'd be much nicer. So yeah, so I need to test it again. So currently I've got auto enroll just disabled because that was just spitting up an annoying error every time. So I need to fix that. I also wonder how much, if there's something in play with the fact that our EFI binary is absolutely humongous right now, and it's actually causing some issue loading it sometimes. So I might try the shrinking the initRD first, so that we actually have an EFI binary that's a manageable size. Then turn on the auto enroll again. And I'll give you some more details and see if we've got any pointers for what to look at there. But that's basically the only remaining issue I think at this point. So that's looking pretty darn good. All right, I think that was long enough of a live stream for everyone. Thanks a lot for everyone following along and asking questions and giving feedback. And thanks a lot to Dan for also being around during the entire live stream and answering questions and looking at what I'm doing and catching my mistakes as I'm literally writing some of those files. So that was super useful. And yeah, I'll do some cleanup, push that up, and we should have another live stream next week. So we'll see if it's still gonna be IncusOS related or if I do something else. If IncusOS, it might be a demo of the state of sysupdate, and then starting to actually work on the management daemon and kind of doing the initial provisioning of this stuff. So I don't need to use like a make file that runs a bunch of Incus commands to push the CSX and all that stuff in place, but just have a daemon that starts automatically on first startup and does that automatically for us. So that's going to be the goal there. Again, thanks a lot for watching. If anyone has any questions, feel free to leave them down below in the comment section. And I'll see you next week. Good one. Bye, everyone.